por las caras que tenemos todos, y lo notarán en mi voz también, que es viernes, y pasaron ya 3 días de la Ekoparty. Bueno, nada, mi rol acá es introducir a Akila. Akila es una ingeniera que tiene una carrera increíble. Trabajó en Microsoft, trabajó en Apple, trabajó conmigo en algún momento, y ahora está trabajando y está liderando el equipo de seguridad de Notion. Y me parece que un poco de lo que va a hablar ella es un poco de una temática que estamos viendo en varias charlas de la Ekoparty, que es un poco la idea de cómo empezar a crear, es decir, que la seguridad no es solo destruir, sino también es crear, y ella va a dar un poco más la perspectiva de esa creación, pero dentro de un equipo de seguridad, no como crear productos desde una empresa externa, sino de cómo los equipos de seguridad actuales, modernos, que trabajan a escala, pueden también crear tecnología para saciar alguna de las necesidades que tienen de proteger la empresa. Así que bueno, nada, dejo la introducción y los dejo con Akila, que disfruten.
Folks, good morning. Thank you for being here, bright and early. It's an honor to speak here at Ekoparty, and I thank you for having me here. So for the past few days, you've learned so many aspects of security: threat intelligence, exploitation, and engineering. Continuing down that path, I want to spend some time discussing another possible direction of taking your security career, through building versus breaking. And it's a little more about how my journey and security has shaped up. So to kick things off, a brief agenda. I'll go in depth on my career journey and how it changed my views on security, my perspectives on the definition of security in big versus small companies, the various events that have now impacted the tech landscape and have accelerated the inevitable. I'll talk about opportunities to capitalize on to help build more secure products. And the goal through a lot of this discussion today is to highlight various aspects you should consider when you're trying to make more informed decisions on how you see yourself growing and evolving in this particular field. I personally really like Pokemons, so you'll see a lot of GIFs throughout this entire presentation. It's also a fun morning presentation. So to kick things off, a little about me. I studied engineering, where I was taught various aspects of computer science. It gave me a very high-level view of security, but not enough to have an opinion, to have a strong, opinionated thought about this field. Microsoft was my first job out of college, and it gave me perspective of security at scale. Security at Microsoft could mean many, many, many things, simply because Microsoft does everything, and you build software and service for billions of people. From there, I moved to Apple and worked as an engineer in the security engineering and architecture group, and then I moved to becoming an engineering manager there. Apple changed the way I looked at security and privacy. I learned more about usable security and to make a real positive impact to your customers. It doesn't matter how secure your product is if your customers actually don't know how to make use of those features to make themselves more secure. So you being incredibly talented and smart, it doesn't matter if no one knows how to do the thing that you told them to go do. Privacy and user trust principles are often baked into the ground up. And the benefit of working in a big tech company that has seen it all, like Microsoft and Apple, it gave me the benefit of learning by standing on the shoulders of giants. So often, before I would make a mistake, I would have some support system that would give me some guidance on, hey, you should probably consider a different approach than going down this path, because many of us have already been down this path. As I grew in my career, I realized I wanted to learn more about software security adjacent tech stacks, so trust and privacy being them. So I took a different adventure by joining Lyft, specifically the privacy engineering and the data security teams there. And most recently, I joined Notion's security and trust engineering team. Notion is a smaller company, much smaller company, and it does primarily office productivity software. So what does security at a big tech company actually mean? To talk a little more about Microsoft and Apple generally, and take all of this with companies that build software for other engineering teams, so for other software companies. Firstly, I'm not a spokesperson for any of these companies, so take everything I say as my perspective. It's what I did eons ago, and things have probably changed in the delta since when I worked at the companies to where I'm right now. Security, firstly, at both these companies are defined by who their customers are. Microsoft is huge in the enterprise space, so think of products like Azure and Office 365. Apple is primarily a consumer product, so think of iPhones, Mac, Watch, those types of devices. So moving on to products then. Microsoft has many security teams. You ask, in Microsoft, if one security team knows the other, they probably don't. And that's because they have so many diverse products that are shipping such different software. The type of engineering that would be required for Windows is going to be very different from the type of engineering that's going to be required for Azure and Office 365 because your baseline technologies are very different. This often honestly took me by surprise because I assumed that it's one Microsoft. But it does make sense. A backend service, or if there's a bug in a backend service, it would be fixed in a matter of hours. You wouldn't even know that there was a bug that needed to be patched because all of a sudden there was just an update because it's all server-side. You know when Windows wants you to take a patch, and it takes a couple of days with all engineers on deck to actually get it out because it has to go through intense testing. The next is career. So you understood what the types of customers are, the types of products that you need to ship out. A career in Microsoft could literally mean anything. You take any field of security and it exists. There's security design where you can think about it more proactively. There's threat modeling and response. There's threat intelligence. And threat intelligence could be detecting and monitoring for the systems itself or detecting and monitoring for your customers like endpoint detection systems or Windows Defender or whatever. You have program management. You have security feature development. You have hardware software solutions. And then you have security based on if you are developing it for enterprise customers versus developers versus end customers like us. So response, and the reason I want to call out response is a lot of my Microsoft career was focused on this, but also because a lot of people write security bugs and send them to Microsoft, either for their bug bounty programs to get them fixed. Threat intelligence and response teams at Microsoft are pretty big. They're about 30 to 40 individuals, at least this was before the time when I left. For all the security researchers who regularly submit bugs, they do look at your bugs and they do get back to you. However, if you'll notice, the timing could be very unpredictable. And that's because they get hundreds of emails every day. Some of them may be real bugs, some of them not real bugs. So you want to try and front load as much information as possible to get the quickest response. But response at Microsoft could also mean you have an engineering team, you have a program management team, you have a release management team. All these teams need to work together to help evaluate when the bug needs to get fixed, and then either take a fix immediately if it's a server-side fix, or take a fix eventually if it actually affects software products, so Patch Tuesday and all of that. On the flip side, when I worked at Apple, response was actually a lot leaner. There was a lot more automation generally in Apple's culture. So we had to do as much as we can to make the machine do the thing for you. There were fewer security teams at Apple. And again, the reason being is because Apple has lesser products. There's not much of the enterprise space there, right? As compared to like the sheer amount of things that Microsoft ships out. You've also got lesser versions of macOS and iOS software to maintain. You have like, I think N-2 at the most. And at least when I worked at Microsoft, there was a time when we had to maintain N-25. So you've got 25 different variations of software. So shipping security bugs for that just takes a lot longer. Either way, these are global tech giants and shipping software for billions of people worldwide. It makes sense for them to generally have bigger security teams. Security at a smaller tech company is actually very different. When you work at a smaller company, or a company who is shipping security for a product that isn't software. So think like banks, oil and gas, even like stores that are things that serve restaurants, your point-of-sale system and all of that. Their security is to drive the business. It isn't the business. Your definition of security changes. It's less about creating best-in-class mitigations. It's about building a foundation of security to help push defense in depth for all of your solutions and your most susceptible assets. It could require your engineers to fix very critical bugs, but it could often be as simple as implementing an identity provider internally. You need to figure out what your company needs and then use security as an enabler, not focus on what could be the best possible, interesting work that you could instead do. As a smaller company, you have very targeted customers, and they will tell you exactly what they need from you for you to get their business. If security becomes their ask, then as a security team, you need to chip in and do what it takes. This could be getting a SOC compliance or a PCI compliance for folks in the financial industry. It could also mean just making sure you can attest that the assets that the company stores in your systems is actually secure. So doing the basics that you need to do to help drive revenue. Sometimes that does become the security charter, and I think it's a very meaningful charter because you actually move away from being a cost center to a profit center. As your career evolves, you will realize that working in a smaller company or working in a company that is not creating tech for tech will give you a lot more breadth than depth. You end up becoming the jack of many trades, and often very quickly. They don't know who's going to go solve this problem. You have some subject matter expertise in an adjacent area, so why don't you go solve it? So take advantage and capitalize on a lot of those opportunities. Actually, one more thing to call out here is you are often going to be on the hot seat of defining build versus buy. From my conversations in the last few days, I've learned a lot more about how security decisions get evaluated. It is interesting and important to consider security solutions that actually foundationally help you when you're thinking about build versus buy decisions. Most of them are very point systems. So take a step back and learn about how this buy solution can actually impact your long-term roadmap, not just the short-term one-year plan. So we briefly discussed my career journey and then my perspective of working in a big versus small company. So let's move on to the observations on how the security business is actually still booming despite of the very deteriorating macroclimate. The first change is the pandemic. It changed the world quite a bit. In the past few years, we have seen companies make significant adjustments to accommodate it. The pandemic brought about fundamental change that disrupted the core of how people interact with work systems. It now happens everywhere, from significantly less controllable environments. Remote work, economic uncertainty, and an overall breakdown of the known societal norms has changed the way the world operates. It's a lot more common for you to now get onto a Zoom call than a real phone call with someone. To be fair, we were already headed down this path. Zoom didn't come up during the pandemic. Like Google Meets didn't happen during the pandemic. We already took advantage of a lot of these VoIP technologies. But the pandemic was a forcing function to accelerate the pace of adopting these changes. And now it's our job to help keep up with these disruptions. So talking about the most obvious change and how it affected security is remote work. The move to remote work has accelerated the move to distributed networking and decentralization. Individual devices and accounts are the easiest points of entries for most hacks. Scaling of remote work has multiplied enterprise security risk and has accelerated the move for minimal trust on devices. It has also increased monitoring. So organizations now need a more scalable way of answering questions that keep coming up regarding the identity of an employee. This is a recurring theme. It isn't anything new. As a part of a security group, you often are already doing your analysis on, like, is this user who they say they are? Is this employee who they say they are? The pandemic has exacerbated all of this. Is the person accessing our system actually an employee? What are the resources we should give them? If we should give them these resources, do they have the right education in order to know how to interface with these systems? What software is on their laptop? What additional controls should we have on that software? They just went ahead and downloaded an arbitrary Google extension that seems kind of sketch. Do you have an ability to actually control that? When they're at home and not on a work computer, what can they do and what should they not do? There are lots of things that they should not do, and people have, to a certain extent, broken down these barriers when they work from home. If you finally have to take someone off the company if someone is to leave your company and you have to get someone off-boarded, it isn't an easy thing to do anymore. You need to go figure out what sensitive assets actually live on their machine that you don't really control anymore. And how do you get that ahead of time? So all of this traditionally falls under corporate or enterprise security. It's an area of security I believe most people take for granted. There are plenty of software solutions out there, and it's also the very tech jargon-heavy space. I personally learn a lot more acronyms every day in this space, or maybe on a weekly basis. I come onto LinkedIn, and there's a new blog article about this interesting startup that's doing something with a 3-letter, 5-letter acronym that I'm hearing for the first time. These are fundamentally the same technologies over and over again, repurposed and repackaged. The other assumption we make is that we dismiss this area expecting the internal IT team to take care of it. And that's not the case, because these are the things that often lead to breaches. And it's going to be a security person who has to answer for this, not IT. It also should fall, it makes sense it falls under security's prerogative. It's your responsibility to care about your digital kingdom and your assets. So a few things that I have seen change in the enterprise security space as we've moved towards remote work. The first one is endpoint protection. Significantly better detection, control, monitoring capabilities have, the pandemic has given rise to a lot of these. You have much better event management systems than you previously did, and they help with effortless data ingestion. They also take data now from very common log sources, like you have identity providers, you have your, if you do MFA, then you have your TOTP providers, you have AWS integration that gets built in, you have log normalization as a part of it. And finally, they give you a much better ability of writing detections on it. And they also give you baseline detections that you could just inherit. Investing in a strong endpoint protection system can actually help get you to a more proactive path of ensuring enterprise security. The second one is MDM. A lot of us have worked with VPN solutions. VPN solutions don't really scale when devices start moving to a lot more remote focus, because often you need to now ship a device to someone. They can't come into your VPN network to go work from your HQ or something of that sort. So MDMs, it's given the rise to MDMs or other thinner clients that help keep sensitive devices off individual worker devices that keep sensitive data off individual worker devices altogether, but also give you better control. Finally, more awareness of the security space in general. I think everyone now knows, almost everyone here has been a part of a breach as a consumer, or is aware of at least what's going on in the larger ecosystem. More awareness about overall security industry is the best defense in depth, because a lot of enterprise security has to deal with people management. There's people, process, technology. It is all about people in this category too. So it's not just engineers or security professionals who now have to care about security. It needs to be security education and awareness for everyone. And it needs to be a healthy dose of paranoia, such that if someone in an arbitrary team who has never dealt with tech comes across a sketchy text message saying that we need you to log into the system, they take a step back and think twice. Do I really need to log into the system? Or is this something that am I being the vector of compromise for my company? That is a sort of larger cultural change that needs to happen. The second thing, and personally this is my most favorite, is data ubiquity. Data is everywhere, and hence it needs to be considered as a new endpoint and should be at par with software IP that needs protecting. Traditionally, security has always focused on supporting systems that store data rather than the data itself, and this will need to change. Security dollars are moving towards data, which means that you not only have to create a walled garden around your data, but actually make sure the information itself is kept in a way that will prevent damage if compromised. There are so many opinions about data being the new oil, the new gold of the digital economy. It's now, a lot of actually new systems are also built on data versus code. So it is getting, in my opinion, even more important than code itself. And software engineers are actually working with data as much as they were working with code. In all honesty, you'll have a lot more people in your company work with data than code. And a data here doesn't necessarily mean customer data. It could also mean analytical metadata collected to help understand your customer's user interaction with your actual system. It could be logging information on like how often does the customer log into your device, everything that's pertaining to audit logs about that. It's also actually audit logs of how often your employees are logging into the system. So there are many, many ways of looking at data. It also has a lot of information about monetization. A lot of this information that we collecting, technically Amazon and Google and all these other companies have made data storage cheaper than it used to be, but it's still expensive. There's a reason why we don't just arbitrarily delete everything, because there's a lot of good aggregated information that can help better your products. The rise of data infrastructure, data science, machine learning, and data development toolchain will likely reshape the way we anyway write software. So if data truly is the company's most sensitive asset, how should we go about protecting it? In September, so September 2022, not too long ago, there were multiple companies that had announced that they had been compromised. So let's actually talk about LastPass, since I think they were one of the few companies where a breach actually didn't lead to entire customer data compromise. In LastPass's case, they said that they did not actually find any evidence of malicious actors that accessed any customer data or any encrypted password vaults. And this was because the developer environment there was physically separated from the production environment. The developer environment did not contain any customer data or actually any encrypted vaults. And finally, LastPass employees itself did not have access to any customer's main passwords. So they essentially more or less obfuscated this information from employees, which meant that in the case of a compromise, the amount of information that would actually get leaked would not dissolve customer trust in the product, as compared to a lot of other companies where they've gotten breached and now you have lost very sensitive private information about yourself, and it's out there in the ether. Data security is not an easy solution. To start off with, because there are so many different types of data, you need to have a different approach of trying to secure them, because you cannot take away from data usability. There wouldn't be any point of collecting data if it wasn't usable, and security cannot stop that. So data infrastructure, data platform, and data sciences, it's honestly its own massive space of engineering discipline. You can't expect a security professional to become an expert in that area overnight. Companies such as AWS, Azure, or Google Cloud have started providing have always provided a lot of storage solutions, such as S3, Blob, cloud storage, whatever, but they're also providing a lot more security guarantees in it than they previously have. You have integrations with companies like Databricks and Snowflake, and then each cloud solution will provide you defaults that you can go back and configure. So they're giving you the controls, but they're providing you an ability to keep yourself secure on their infrastructure. If data stored inherently has less value, it means that if it's compromised, for whatever reason the data gets compromised, you will have lesser impact, going down to what LastPass did. Data anonymization or pseudo-anonymization, differential privacy, key anonymity. A lot of these sort of privacy practices actually enable data security. And it's a way a lot of companies are actually driving data security. And then finally, adopting a very similar philosophy from endpoint detection. It doesn't matter how secure your solution is, someone will find a workaround and someone will try to get access to it. So in that case, detection, monitoring, auditing, and alerting has become critical to capture the out-of-ordinary behaviors. You need to access two things. Every access to user data should always be audited, and audit the types of queries actually performed and make sure they're restricted. An arbitrary person in the company should not have the ability to select all records and then export that all into, like, I don't know, a CSV or an Excel and then email them out. So you have an ability to build these types of detections. Two forms of detections. One is on the actual data itself, and then one is actual network monitoring. What is the type of data that's leaving your company? Concepts like data ownership, data stewardship are often talked about. It becomes unscalable in a large organization because most people don't completely understand what should be the responsibilities of a data owner. A data generator may not be a data consumer and may not be a data maintainer. These systems become hard to maintain in the long run because there is no one point of failure, because it's a shared resource. Think of it like a park. If not everyone is responsible for keeping a park clean, then it becomes no one's responsibility. And then a public property, to a certain extent, gets destroyed because of general lack of empathy about keeping it clean. Data is in a very similar boat. It's everyone's responsibility to make sure it's secure, but if it is insecure, it's no one's real responsibility. So how do you own up to handling an area that could be so complicated? A data ownership system, the usefulness of a data ownership system goes beyond security. It helps tackle questions like data quality, which should technically be important to a company if they are making revenue decisions based off of that, it would be nice to ensure that security is plugged into those discussions. So ride the wave that's already happening for a lot of quality-focused decisions. Finally, a lot of these changes are great for security, but they actually drive a lot of user trust and privacy. And privacy, as we know, is getting mandated by a lot more countries than they previously were. So it's always good to have a bit of a head start than you've had, than at least your competitors have had. So moving on to the third change, which is distributed workloads. Distributed workloads is interesting for multiple reasons. It's because it actually reflects the constantly changing environment that we're in today. COVID has accelerated the move to multi-cloud, so people either have multiple cloud environments or they're stuck between on-prem and off-prem. But cloud computing is past the tipping point in our world, and we are going to see a lot more organizations move their applications to the cloud in the next few years than they've historically had, because it was just too difficult to maintain them on-prem during COVID. When you all can't go to work to turn on a server, then what happens? Most mid to large enterprises today use more than one cloud provider, and that's because of reliability issues, disaster recovery, risk mitigations. You want to minimize dependencies, but also cost. If you have multiple vendors, you can always pit one against the other to get more money, right? You want to have a better contract with all of them. There are two sides of the coin with a multi-cloud environment. The good is that most cloud providers have very robust security practices. In all honesty, much better than what you would do for your on-prem solutions, but they are expensive. You can lean on them to provide infrastructure support because they give you baseline end-to-end encryption, they give you really good monitoring and auditing, they give you good access control. The problem, however, with that is they're giving you these solutions. It's what you make do out of it. How do you start figuring out what sorts of SSO mechanisms or role-based access control mechanisms now exist? You have to develop subject matter expertise not on security fundamentals, but how security works in their environment. How would you define role-based access control for all of the folks who needs to access AWS in your company? Should people who access production AWS have the same as staging AWS? Should have the same as maybe some sort of other logging section that you have for your AWS store? It also becomes a mess of fragmented tools. One thing you'll realize is you don't have one silver security bullet that exists. You'll have multiple vendors selling you multiple point solutions that in some capacity integrate with some cloud provider. How do you take all of these arbitrary tools that you've now deployed and make sense out of them? That also gets very, very, very expensive. You need to now hire someone who not just understands security, but now understands, again, security as it pertains to all of these different tools. So my call out here would be very mindful when you get into your build versus buy decisions, because it doesn't make sense for you to buy a security vendor that's, let's say, a Series A startup, because if they go away, you have made a massive business commitment on them providing you some baseline protections. It could lead to you maybe losing compliance certificate, which could lead to you losing business. So again, build versus buy decisions need to go on your technical capabilities of actually understanding what solutions you're buying and being able to recreate it in the lack of, when you don't have the ability to actually continue servicing them. And finally, cost. Cost, it becomes very cost prohibitive. So think about how much money you're going to be using if you deploy this in-house. Think about how much money you'll be spending year over year, because it's probably a service agreement. Another change that I've also noticed is most services are being rewritten to be cloud native. That means the move to Kubernetes or other container solutions are going to be faster than before. Containers enable speed, they enable portability, but they can also create a lot of security blind spots. And they increase your attack surface, because that's now another thing that you need to go maintain. Unpatched or misconfigured containers are risks that you previously didn't have to account for. You now have to you need to have secure defaults in your containers. Kubernetes offers secure clusters, but they're not on by default. So how do you now help your infrastructure organization define what your organization risk tolerance looks like to enable the right defaults for all of these different infrastructure tools that you've deployed? Your security operations response team will actually be very, very important here. And now they're going to be taking on a lot more work than they previously have. They're responsible for ensuring that image scanners deployed to help identify vulnerabilities in your containers are actually kept up to date. They're taking into account third-party dependencies. Vulnerability management gets a lot more complicated. So when folks talk about moving to the cloud because you're getting a lot of guarantees from your provider, that's the case. You are still taking a lot of responsibility for getting it up and running for your engineers. traditionally, again, a lot of people have expertise doing the entire stack. When a portion of the stack is handled by someone else, how do you scale yourself to be able to make the right risk decision on what your gaps look like now? Make image scanning and other security checks a part of your CI/CD pipeline, your continuous integration and deployment pipeline. The sooner you do it, the better, because if vulnerabilities are actually found, you're not going to ever stop a production from happening because you found a security build when you are in the development of your software. So you often, a lot of companies do ship with security risk because you're like, okay, it's not a critical bug. It's not immediately, the attack vector is not immediately obvious. Let's just go ahead with it and we will eventually hotfix it. Those are very, very, very expensive decisions. So how do you start front-loading and catching a bunch of these vulnerabilities ahead of time? Because of the new technologies that exist, you have the ability to do it. You just need to be aware that you need to do it now as compared to before where you probably didn't think about it. In all these cases, you're trying to get security feedback as early as possible in the development lifecycle in order to minimize the security issues from happening eventually. So those were the 3 changes, and spoke about briefly my career, spoke about the changes. So let's talk about takeaways. What are the things that you could probably learn from this conversation? And I'll try to get through the slides relatively quickly to give back your morning. A lot of this is, one of the things to take away from is these changes are happening, whether you like it or not, so it's best to get on it, but also try to use this to help define your security career. There's a lot of, if you're interested in if you have financial motivations, or if you want to just be a subject matter expert in your field, the field itself is changing. There's a lot more money in it than previously was. So how do you take into account a lot of these things to make the most informed decision? So the first thing first is takeaway 1. Security is moving to tech and product development than ever before. Before, security focused on proactive consulting, secure design, pen testing, response. The trends have changed, and companies are going further to not just overlay security as this checkbox. It's become a part of development product lifecycle, and it should be. There's a lot more focus to it than it otherwise has been. But there's a lot more focus on a pragmatic way than it has been. So previously, if a bug was found somewhere during SDLC, which is software development lifecycle, so somewhere during your lifecycle, you could then have a mechanism to eventually patch it. You would go talk to your engineers, be like, hey, could you patch this? Then you would have a risk decision. And eventually, it could come out like, hey, maybe we should hotfix this, or maybe we shouldn't. The problem with a lot of this is it becomes very, very, very expensive. The whole hero phenomena of security can happen once or twice. It cannot happen predictably, and it cannot happen scalably. So you're going to burn a lot of trust with your internal engineering team if you keep doing this over and over again. Security fixes can also be very intrusive and are notorious for causing regressions and bad builds because they often happen in underlying layers. So you need to be a lot more thoughtful about the types of security fixes to take. If it causes a bad build, it means you have more or less lost customer trust. And you are going to have a very difficult time having an engineering team take your fix after this. So everything you believe is secure is insecure till someone proves it, right? And that's a part of our job. An agile and competitive environment helps you figure out what your security bugs are ahead of time. We don't have formal release management schedules anymore because people don't follow the waterfall model. You're not going to have a specific 1 week or 2 week window where you can test your product. You need to go figure out what is realistic risk management. Firstly, stack rank your bugs. You are an engineer, you are a security engineer or a security program manager. You have some subject matter expertise in security. You should be comfortable enough making a call of what your critical and high bar is as compared to what your low and medium bar is. You can't punt it over the fence and have the engineering team decide to fix all of it. You need to work very closely with them to make decisions on, okay, fix critical in a week, fix high in a month, maybe never fix median because it's just not important enough. And that is your risk tolerance. Help your company define your risk tolerance. If, let's say, you're in the healthcare space, right, and your medium bugs could still result in healthcare information getting leaked, then maybe that your risk tolerance should be a lot higher, and maybe your risk tolerance should be low bugs don't get fixed, not medium. You can't expect someone to make these decisions. Get involved with how the product gets developed. Get involved in informing what are the bugs that need to get fixed. Get involved in informing what your customers should expect and what are the types of security guarantees your customers should expect, because an engineering team most likely is not going to be provisioned enough to be able to make those decisions for security. The second one is great. You think you're doing all the right stuff, you're trying to account for risk, that's beautiful. But Let's talk about a very basic question. Why should an organization care about security? Will it help them get more money? Will it help them get more customers? Will it ensure that your customers are not actually leaving you? It's a very jarring question to ask at a security conference, but that has been with very organizations I've worked with. And you can't really blame them for that. Everyone is in the business of making money. If security is a cost center, be very mindful of how much cost your cost center actually takes in the amount of money your company has allocated. You can't come to the drawing board and be like, security is important, we got to fix it. How much money is worth it? What is the return of investment? So start with being very practical and understanding who your stakeholders are and why they care about security. If they don't care about security, why should they care about security? Sometimes the right answer could be, maybe they don't care enough about security because your customers have historically said that they don't care. You kind of need to make those informed decisions. You need to be able to articulate that effectively because you're creating the security story for your company. Constantly ask your audience a question. It's precision question and answering. Ask them why they should care. Let's say if a customer comes and tells you, hey, I don't think I care about security, I want the cheapest solution, then ask them a bunch of pointed questions because sometimes maybe they expect certain things by default, just like you would when you buy AWS or Google Cloud or whatever, you expect it by default. You're not going to pay more for it because you're like, it should be bundled into the product. The same way, do your customers actually expect that from your product? Is that why they're not asking you explicit questions about that? Try to minimize the amount of acronyms you use, only because that makes security a lot more intimidating. Often people are actually talking about the same thing. When you hear the concepts of zero trust or shift left or what's it called, least privilege or something of that sort, it's all about preventing malicious people from entering your systems. Identifying is the user who they say they are. If you go to an engineering team and be like, oh, we need to go implement a zero trust model, they're going to ask you, they're probably going to ignore you because you're spouting tech jargon that doesn't make sense, and the barrier of them to understand what you have to say has increased. As a good security professional, you need to get your barrier really, really low because you need to be approachable. Security needs to be approachable. It can't be intimidating because the more intimidating it is, honestly, the less money you're going to get in order to do the work that you want to go do. Don't create an ivory tower of security checklist for your engineering team because, again, you're making it intimidating. You will be implementing solutions that will reduce developer velocity. You should be very upfront about that, and you should be very upfront about the cost. So, for example, you don't want everyone in the company to access all your customer data. You're now going to provide it only to explicit engineers, or they have to go through a system of checks and balances so that you know who has accessed what. You are taking away the concept of data ubiquity. You're taking away the fact that multiple people can access certain things. It cannot come as a surprise. The fundamental model that I follow in security is no surprises. You need to be as predictable and boring as possible so people know what they're signing up for. Predictability ensures scalability, which ensures more money for your business. Be upfront about the cost of figure out what your developer velocity impediment is going to look like. How much slower are you going to make engineers or product managers or data science engineers? Is it acceptable by the business? If it isn't acceptable by the business, what do you need to do so that you can come to your min bar of acceptability, but also security guarantees? Show how security supports the overall business objective. Understand real risks to the company. Change your metrics to accommodate that. It's very easy to fall into the trap of emulating compliance checkbox. So create a security checklist that actually enables security in a very measurable way. So to give you an example, we fixed 10 critical bugs in the last quarter in 30 days. We prioritize fixing only critical bugs to accept the risk for all others due to ABC product release. What you have done with this statement is you've explicitly called out your risk acceptance bar. You've clearly shown why your risk acceptance bar is to this particular limit because we had to go prioritize shipping this product. And you have been very upfront on the fact that this is the data of how much we have fixed. You can go beyond talking about like how many engineering hours and customer risk and money and a lot of these other things, but you're trying to be as measurable as possible with your business. And the reason you want to be very measurable is performance, reliability. They all follow the same model as security. people assume your service is always going to be performant, right? Like if let's say, xyz.com is not reachable, you're probably not going to do business with that site anymore because it doesn't have a few milliseconds load time. Security follows a similar model. If your customers expect something from you, the business performance reliability, again, specifically those two, have figured out the right sorts of metrics to talk about why people should spend money supporting this. Security should probably learn from those businesses. Finally, as an industry, we don't really have a formal path to progress in our careers. And careers in security are a relatively recent occurrence, and there are a lot more specializations. People often get exposed to domains or subdomains of security through work, through colleagues, through friends, through mentors, through a lot of Discord or other Slack groups and all of that. I came across Marco Lancini's mind map on various security careers, and honestly, I couldn't have put it any better, which is why I put it up here. There's a link to there, so please feel free to check it out. But it actually provides you a very good perspective on the breadth of depth of security. It also provides you a perspective about the fact that security is not this bubble that you actually expect. It falls under compliance. It has a lot of correlation with privacy and trust and safety. It actually has a lot of correlation with services and software development. So if you look at application security, infrastructure security, DevSecOps, CloudSec, mostly, if you're not a good infrastructure engineer, you wouldn't know how to write security for infrastructure. So you have fundamentally changed the way you fundamentally changed what security actually means, because it's now getting subject matter expertise in different stacks. There are times when security can get really hard, and it's very demoralizing. Knowing the fact that you are the one making prioritization decisions for a company's risk can also be very, very intimidating and exhausting. It's a decision fatigue. You're constantly making these sorts of trade-offs and calls off. You constantly try to convince people why they should or shouldn't care about these things. And you often do not have a safety net. What if you make a bad call? It isn't easy, but I think we're all here for a reason, right? I mean, it keeps us busy, it keeps us challenging. No pun intended, it gives us job security. But it also gives us the joy that at the end of the day, our users trust and believe in our product, and we're shipping good code. And yeah, thank you for giving me this opportunity to discuss my thoughts today morning, and thank you for being present here bright and early on a Friday morning. That's it from me.